Welcome to Mrs. Lee's Chemistry Academy, where no students are left behind. Today we're going to talk about oxidation-reduction reactions. The learning objectives from College Board: that we can balance redox reaction by knowing conservation of atoms. That we can take an observation or particle view and write chemical equation and justify it in terms of being a redox reaction and recognizing what is a redox reaction. So redox reaction involves the transfer of electrons between the species oxidized to the species that's reduced. We like to learn by using the acronym LEO-GR, meaning losing electron is oxidation and gaining electron is reduction, or oil-rig. Oxidation is losing electrons, reduction is gaining electrons. And one thing we must be aware of is that the number of electrons transferred, either lost or gained, must be equal. Today we're going to dwell on the single displacement reactions, and there are 4 types. 1, the hydrogen displacement either from water or from acid. And then the metal displacement, and then the nonmetal halogen displacement. So we start off with hydrogen displacement from water. An active alkaline metal or alkaline earth metal reduces hydrogen from water. Or, I placed it with an asterisk, a less active metal is reduced by hydrogen gas. Now let's begin with the first question. A small piece of sodium is placed in a beaker of distilled water. So we have sodium, metal, placed into water, liquid. Add the sodium will displace the hydrogen out of water to become sodium hydroxide, and the hydrogen is reduced from water into hydrogen gas. So this is aqueous, that is gas. And we balance it by putting a 2 coefficient in front of sodium, 2 in front of water, and 2 in front of sodium hydroxide. The only one that we can dissociate will be the aqueous solution into 2 moles of sodium ion and 2 moles of hydroxide ion for the net ionic equation, and nothing to be cancelled. The next one has to do with a small piece of calcium metal added to hot distilled water. So we start by placing calcium metal into water, liquid, and that will form calcium hydroxide. By the way, I hope you know the name of calcium hydroxide, which is also lime water, which is a confirmation test for carbon dioxide gas because it turns it cloudy. And now we form hydrogen gas. So we balance, we put 2 in front of water, and I think everything's balanced. And the only species that I can dissociate would be the calcium ion and the hydroxide ion from the soluble calcium hydroxide. And the next one is hot hydrogen gas passed over heated copper 2 oxide solid. I placed an asterisk here because it really has nothing to do with water, but it has to do with hydrogen. So we take the hydrogen gas, pass it over copper 2 oxide solid, and the hydrogen will displace the copper out of the solid into copper metal, and water liquid is formed. And there's nothing to be cancelled because it is does not involve ions in solution. So here's a recap of my previous work for you to follow. You may want to pause the screen so that you can jot down what you need to learn or practice writing with it. Now the next category has to do with hydrogen displacement from acid. That involves an active metal reducing hydrogen from acid. The first one, magnesium pellets are placed in 1 molar hydrochloric acid. So we put magnesium palette into hydrochloric acid, aqueous, and magnesium displaces hydrogen to form magnesium chloride solution and hydrogen gas. And we balance with the 2 in front of the hydrochloric acid. To write net ionic equation, we dissociate the hydrochloric acid into 2 moles of hydrogen ion and 2 moles of chloride ion, and the magnesium chloride we dissociate into 2 moles of magnesium ion and 2 moles of chloride ion. And now we cancel out the chloride ion, and we have the net ionic equation. A piece of zinc is added to solution of hydrobromic acid. So zinc metal with the hydrobromic acid, which is strong acid, to form zinc bromide. Zinc will replace hydrogen, zinc bromide solution, and out comes the hydrogen gas. And balance with the 2 here. And to write net ionic equation, we just take the hydrobromic acid, dissociate it into 2 moles of hydrogen ion and 2 moles of bromide ion, and with the zinc bromide solution, we dissociate into zinc ion and bromide ion, and we can cancel out the bromide ion for the net ionic equation. So here's a recap of my work in the previous page. You may want to pause the screen to follow it. Now the next one is metal displacement, involving a more active metal oxidized by a less active metal. For example, a copper wire dipped into a solution of silver nitrate. So we have copper, which is a reddish brown metal, placed into the colorless clear solution of silver nitrate. Now the copper will be dissolved in the solution to form copper nitrate solution, and this is blue, and out comes the silver metal, which is silvery gray, and we balance with a 2 and a 2 here. And to write net ionic equation, we go ahead and dissociate the silver nitrate into silver ion and nitrate ions, and the copper nitrate solution into copper ion and nitrate ion. Now we can cancel out the spectator ions that involve the nitrate ion, and we have the net ionic equation. The next one deals with cadmium metal oxidized by adding it to a solution of copper 2 chloride. So we put cadmium, Cd, metal into copper 2 chloride, CuCl2 aqueous solution, and that cadmium displaces copper to become cadmium 2 chloride solution, and out comes the copper metal. And this is already balanced, so we dissociate the copper chloride solution into copper ion and chloride ion, and we do the same to the cadmium chloride to dissociate into cadmium and chloride ion, cancel out the chloride ions, and you have the net ionic equation. Another problem deals with magnesium metal put into iron 2 chloride. So we have Mg solid put into FeCl2 Aq. Magnesium being more reactive than iron will form magnesium chloride solution and displaces the iron out. And so we have the iron chloride that can be dissociated and the magnesium ion that can be dissociated from magnesium chloride, and then we cancel out the chloride ion, and we have the net ionic equation. The next one deals with zinc metal put into solution of nickel 2 nitrate. So we have zinc metal put into nickel 2 nitrate solution, and then becomes zinc nitrate solution and displaces the nickel out. So again, you can dissociate the nickel nitrate into ions and the zinc nitrate into ion, and you can cancel out the nitrate ion. And now you have what's left as a net ionic equation. And then the next one, the last one of this category, solution of copper 2 sulfate spill onto a sheet of aluminum metal. So we put copper sulfate, the blue solution, added to this silvery aluminum metal, and it becomes aluminum sulfate solution. Make sure you write the formula correctly, Al2SO4 AQ, and copper metal. Take care to balance it. We would have 2 aluminum here, and we need 3 copper sulfate and 3 copper. Now it's balanced, so when you dissociate it, you would dissociate this into the copper ion and the sulfate ion. Each one has 3 moles, and that into 2 moles of aluminum 3+ ion and 3 moles of sulfate 2- ion. We can cancel out the sulfate ion, and we now have the net ionic equation. So it'd be good for you to review your formula so that you feel comfortable in writing these equations. Here's a recap of my earlier work for you to follow, and you may want to pause the screen to practice writing it. Now the last category in the single displacement has to do with non-metal displacement. A more active halogen is reduced by a less active halogen. Okay, chlorine gas, an oxidizing agent, is bubbled into solution of potassium bromide. So we have chlorine gas. Now if it is an oxidizing agent, meaning its cell will be reduced, added to KBr solution. The chlorine gas is kind of yellowish green colored gas, and now we make potassium chloride solution, and out comes this reddish brown bromine liquid. And so we balance with a 2 and a 2 here. Now you write net ionic equation, dissociate into 2 potassium ion and 2 bromide ions, and on the product side 2 potassium ion, 2 moles of chloride ion. Now cancel out potassium ion, and you have the net ionic equation. And liquid bromine, the reddish brown liquid, carefully added to solution of potassium iodide. Because bromine is more reactive than iodine, so it's going to displace it out to form potassium bromide solution, and forming the iodine, the purple solid, silver purple solid, and you balance with a 2 here, and you dissociate into 2K plus ion and 2I- ion, and 2K plus ion and 2 bromide minus ion, cancel your potassium ion. One thing I need to mention is that fluorine is more reactive than chlorine, more reactive than bromine, more reactive than iodine, and therefore the displacement will happen in this fashion. Here is a recap of my earlier work. I hope that you find it easy to follow. To sum up what we have learned today, first we define what is oxidation and reduction reactions by the transfer of electrons. And 2, we predict the products in single displacement reaction and write net ionic equations for hydrogen displacement, metal displacement, and finally, non-metal displacement. I hope that you have found the above lesson helpful to you. I welcome any comments from you, and I hope to see you again next time.